All right, so just to repeat, your quiz is Thursday. I'll write it up here. Thursday on 8.1 to 8.4, and there will be a practice quiz with solutions online today. All right, so we're going to be talking about trigonometry. What trigonometry is if you break down the actual word, it comes from two words in Greek. Trigon, meaning triangle, 3 sides, right? Like a 15-agon is 15-sided polygon. Trigon meaning triangle, and metron, angle. So really we're looking at angles in a triangle. Now, suppose you have a triangle, and you know, just for fun, you measure one of the sides of the triangle and you see that it's 3 centimeters. And then you measure another side and you see, it's 6 centimeters. And you know, immediately you say to yourself, oh, look, that, you know, one is 3 and one is 6. One is double of the other. There you have a ratio of 1 to 2. They have a ratio of 2 to 1, right? When you compare like that, when you compare the lengths of sides, you're actually, that's trigonometry. Okay, so that's what trigonometric ratios are. A trigonometric ratio is just a ratio of the lengths of sides of a right triangle. All right, and we do this with right triangles. There are 3 most common ratios are the sine ratio, the cosine ratio, and the tangent ratio. Okay, those are the most common. And basically all they are is like the sine, you just take 2 of the sides of the triangle and you compare the lengths. For the cosine, you take a different pair. For the tangent, you take a different pair. Okay? Now, how do we label our triangles? Usually, the vertices or the angles are denoted with capital letters A, B, C. And it doesn't really matter which one is your A, which one is your angle B, and which one is your angle C. But what does matter is this. Suppose this is your angle A, right? That gets a capital letter A. The side opposite to it, this one, gets a lowercase a. And if this is your angle B, the side opposite to it is lowercase b, capital C, lowercase c, and so on. Okay? All right, now, how do we write these ratios? Now, suppose you wanted to find the sine of A. It's abbreviated as SIN, A. Never sin, always sine. And when you're writing a trig ratio, it has to be attached to an angle. So you can never say sine is equal to. No. Sine of what? It's always sine of some angle. Never leave that angle out. So, okay, so let's talk about these then. If you have a right triangle like this, okay, it has to have a hypotenuse, right? In this case, where is the hypotenuse? It's C. C is the hypotenuse. Now, if I'm looking at angle A, so to take these ratios, you first have to identify the angle with which you want to work. And suppose I want to work with angle A. Now, the hypotenuse is always going to be C, no matter what angle you're looking at, no matter how the triangle is oriented. Now, you have 2 other sides left other than the hypotenuse. Those are the legs. One of the legs is touching angle A, adjacent to angle A. The other leg is not touching angle A, and it's opposite angle A, right? So this is the leg opposite to A. This is the leg adjacent to A. So now we've identified 3 of our sides, okay? What I'm going to do next is this. This is how the sine of A is defined. The sine of A is the leg opposite to angle A, so it's the opposite side over the hypotenuse. So A over C, that's the sine of A. Okay? Now look, suppose I want the cosine of A. Cosine says take the adjacent side to A. Which side is it here? B. And divide it by the hypotenuse, C. So the cosine of A is B over C. Cosine is abbreviated COS, never cos, never. Just cosine, okay? The last one is the tangent of A, abbreviated as TAN, never tan, okay? Always tangent of A. And that one says it's the opposite leg over the adjacent leg. So here, if angle A is what we're talking about, the opposite leg is A over the adjacent B. A over B, okay? Now, we find sine, cosine, tangent of the acute angles of the triangle only. So in this case, which angles would qualify? Angle A and angle B. And here we went through, the ones for angle A. What if, though, you were looking for sine of B? Sine of B, again, is going to be opposite over hypotenuse. So now you look at angle B. Which one's the opposite to B? B over what? C. Okay? All right. Now there is a great mnemonic to help you remember all of this. It's SOHCAHTOA, and it's like split up into three. SOHCAHTOA. One for sine, one for cosine, one for tangent. So what this says is sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So if you just write that, like at the top of your test, you don't even have to think too much about what you're doing. All right, so let's move on to the next page. Here you have a triangle, and it says to find the sine, cosine, tangent, and so on of R and S. So again, I'm just going to write this to guide us. SOHCAHTOA. All right. I need to find the sine of R. So what I do is I say, okay, here's R. First of all, identify opposite, adjacent, and hypotenuse. The first thing you want to identify is the hypotenuse, because that's never going to change. So where is the hypotenuse here? Right, that's the hypotenuse. So between the other two, which one will be the adjacent side? TR, this one is the adjacent. That means this is the opposite. All right, now it says to express each ratio as a fraction and then as a decimal rounded to 4 decimal places. I'll talk about that in a second, but let's do the fractional ratios first. So sine of R, sine is opposite over hypotenuse. So what over what? 4 over 5. What about cosine of R? 3 over 5. What about tangent of R? 4 over 3. Now, decimal equivalence. It is the rule, it's accepted, that when you convert these to decimals, so all you would have to do is like 4 divided by 5, 4 divided by 3. You have to go to 4 decimal places, and then you have to round properly. Why 4? Because it's 4, okay? Except when the decimal ends. So for example, if you have like 1 over 2, it's just 0.5, not 0.5000, okay? So 3 over 4 would just be 0.75, and that's it. So here, what would 4 over 5 be? 0.8, that's all. What would 3 over 5 be? 0.6, and this? 1.3333. No bar over the 3, okay? You just end it and you round properly. Okay, so now we're going to do sine of S. For sine of S, now we have to switch the angle that we're talking about, right? So you have to redesignate your opposite and your adjacent. Now, is the hypotenuse going to change because we're looking at a different angle? No. All right, so if we're looking at angle S, which one is the opposite now? This one is the opposite, and this one is the adjacent. So, what's sine of S? 3/5, which is 0.6. What's cosine of S? 4/5, which is 0.8. And tangent of S, opposite over adjacent, is what? 3/4, which is 0.75. Now, any patterns? Any observations? That the sine and cosine, the sine and cosine for the different angles switch. So for example, the sine of R is the same as the cosine of the other angle, S. The cosine of R is the same as the sine of the other angle, S. Okay? And what happens with the tangents? One is the reciprocal of the other. Okay? And that's not a coincidence. That's always the case. Okay, so we only do these for acute angles, because then, you know, the hypotenuse and so on, they're just defined differently. All right, take out your calculators, and please remember that you have to bring a scientific calculator to class with you every single day. Okay? That is. All right, so now here, we want to find the sine of 57, and on your scientific calculators, actually, it's the same as this. The fourth row down has your sine, cosine, and tangent buttons here. All right? So now, sine 57, just type it in as you see it, press enter, and this is what you should get. If you got anything other than this, stop now, raise your hand, so I can tell you what's wrong. It may be that you're in the wrong mode. You have to be in degree mode. So we go to 4 decimal places. It's 0.8387. Okay? What do you mean? You need it. You'll see now. We're going to solve word problems with this. Okay? Okay, so here's another one. I'll tell you right now. Well, what this means is this. Sine is the opposite over the hypotenuse, right? So there is some angle here. It's 57 degrees. And if you measure the opposite side and the hypotenuse, and if you divide them, that's what you get. So, well, it knows. It just knows. Right, but their ratios would be the same. The opposite leg divided by the hypotenuse will always be the same. We just learned that. Thank you for, yeah, thank you. All right, similar triangles. I know, okay. So, here we have the cosine of 60. So let's type that in. Cosine of 60. Enter. 0.5. Now, did we have to put that in the calculator? Well, let's see. Remember, 60 is one of our special angles? So if I have a triangle, 30, 60, 90, if this side is 1, what's this side? 1√3, and this is 2. Okay? 1√3 and 2. Now, cosine of 60 is the adjacent side over the hypotenuse, which is what? 1/2. So now you can do that, like, you know, while waiting in line at the grocery store. Okay. So tangent of 30 is point what? 0.77 4. Will I take points off for not rounding properly? Yes, I will. I am completely serious. Sine of 85, plug it in, what do we get? 0.9962. Okay, so let's go back here for a minute. Now, why do we use this? How do we use this? Next section is all applications, so you'll see exactly where we use it in real life. But to build up to that, suppose you have a triangle. You know what one of the angles are. You know what this side is. You're missing another side. Now, in the last section, you had similar things, but they were all special angles. So you could just figure it out using the special triangles. But here, it's not that way. So, look at how you approach this. Circle the angle. Okay, that's the angle you have. Now, of the two sides in question here, okay, there are two sides that are the key players of this problem. You have to identify them as adjacent, opposite, hypotenuse. Okay? So if you look at this one, the 19, is this adjacent, opposite, or hypotenuse? This is adjacent. Well, what about this one? Opposite. Okay? Now, again, you need to use your SOHCAHTOA here. What do I have? I have opposite and adjacent. So run down this list. Which one uses opposite and adjacent? It's the tangent. All right, so now, you have to write down the expression. Tangent of what? Tangent always wants an angle. What's the angle here? 24. Tangent of 24 is equal to opposite over adjacent, which is x over 19. Tangent of 24 is x over 19. Now I need to solve for x. So if it's x divided by 19, what do I have to do to get rid of it? Multiply by 19 here, multiply by 19 here. These go away. So x is 19 tangent of 24. Okay? So what do? I plug that into my calculator. 19 tangent of 24. Here, 8.40, 8.5. It says to round to the nearest tenth, 8.5. Now, when you're looking for just the straight tangent like we were here, it's always 4 decimal places. But in application problems where you need to find a side or you need to find an angle, we just go to 1 decimal place. All right, so x is 8.5. All right, let's do this next one. My angle is 62 degrees. I circle that one. So let's identify that x and the 60 as adjacent, opposite, or hypotenuse. What is the 60? Hypotenuse. And what about the x? Adjacent. So which one in the SOHCAHTOA deals with adjacent and hypotenuse? AH. Cosine. All right. So now, cosine of what? Cosine of 62 equals the adjacent over the hypotenuse. And I multiply by 60. And I multiply by 60. These go away. So x is 60 cosine 62. And that is 28.2. Okay? Do it again. 60 cosine 62. Plug it in. Okay. Now here it says to use a special, it says to use a special right triangle to express these as a fraction. So again, these are the kind kinds of stuff that you could do, waiting in line somewhere. So tangent of 30 means you need a 30, 60, 90 triangle. Well, let's draw a 30, 60, 90 triangle. 30, 60, 90. Okay? What are the sides of a 30, 60, 90 triangle? X, x root 3, and 2x. Now, tangent of 30 means we need what over what? SOHCAHTOA. So opposite over adjacent. Now, which one here is the opposite side? X, and the adjacent? Right. Oh my. Okay, so I draw my 30, 60, 90 triangle. All right, so SOHCAHTOA. I want tangent, which is the TOA. So tangent is opposite over adjacent. This is a 30-degree angle. This is the opposite, and this is the adjacent. So tangent of 30 is x over x radical 3. X's go away. I have 1 over radical 3. This is root 3 over 3. So that's the answer. All right? Okay, so the x is canceled. Now, the sine of 60 needs another 30, 60, 90 triangle. Okay? This time I'm going to draw this differently. I'm going to orient it differently. I'm going to put the 60 here, 30 here, 90 there, and I'm not going to use x's. I'm just going to call this a 1. If that's a 1, how big is the hypotenuse? 2. How big is the long leg? Root 3. All right, now, sine is opposite over hypotenuse. So this is equal to, if I want the sine of 60, which one of these three sides is the opposite? Root 3. And which one is the hypotenuse? 2. So this is root 3 over 2. That's it. Right. All right. Now, in these problems in example 3, we were looking for a missing side. Okay? In a triangle, you have 3 sides and you have 3 angles. Well, what if you know the sides, but you don't know the angle? So for that, we need a modified version of what we're doing. Okay? That brings us to inverse trig values. This is for a missing angle. So you have to, when you get a problem, in the beginning it might be confusing, but when you get a problem, identify. Am I missing a side? Am I missing an angle? If you're missing an angle, you have to do it differently. Okay? All right. Look at this equation here. You have that the sine of A is 0.4325. Okay? So let's write that here. Okay? Now, if I have 3x is equal to 6, how would I solve that if it's 3 times x equal to 6? You divide. If this is multiplication, I have to do the inverse, right? So I could do 1 over 3, and whatever I do here, I have to do the same thing there, right? So I'm doing the inverse of multiplication. Well, here it's the same thing. If you have sine that you want to get rid of, you have to find the inverse sine, like this, of this. And you do the same thing to this side, inverse sine. Okay? And that minus 1 as the exponent, that means inverse sine. Okay? Well, how do you do that? you go back to your calculator. Now, you see here the sine, cosine, tangent, right? Right above that is inverse sine, inverse cosine, inverse tangent. And you get there using your shift, okay? So shift sine is inverse sine of 0.4325. It's second or shift. Either second or shift. So that's the angle. Okay? Now what happens here is the inverse and the sine cancel each other out. So A, okay, these make each other go away. A is 25.6 degrees. So that's the angle A. Okay? This one too, yeah. Whether you're looking for an angle or a side, that's what you do. Huh? I'll come over in a minute. So here, if you have sine of A equals something, in order to find the angle, you have to do inverse sine, inverse cosine, inverse tangent. Okay? All right. So let's do this one. Tangent of A is 1.4176. Let's find inverse tangent. So you have to do it the same way. Second tangent, 1.4176. 54.8 degrees. All right? Remember to put the degree sign. Okay, go ahead and do the next one, sine of B. All right, so B is 39.1 degrees. Remember to put the degree symbol. Those are the units. Okay? All right, find the value of x here. Look at all my missing, like when I write equal signs and stuff, they just disappear and then they end up there. That's like, okay. It's down there. Okay, go ahead. Okay, let me run through the first one. So you have to identify what you have, what you're missing. Okay? What we're missing is an angle. Okay, now identify the other key players. You have some sides given. Label your sides as opposite, adjacent, hypotenuse. So which of the three is the 6? Adjacent. What about the 15? Now, what I have here is opposite and adjacent. So again, SOHCAHTOA. Okay, this is going to be your best friend for a little bit, right? Opposite, adjacent, that's which one? Tangent. So now, you write an expression, you write an equation for the problem. I have to see an equation. I don't just want you to plug numbers in and give me an answer. I want to see the equation. And the equation is this. Tangent of x is equal to 15 over 6. I must see this one. Okay? You want to simplify? Go right ahead. You don't want to simplify? You don't have to. But this step, I have to see it. So now, you can immediately say x then is inverse tangent 15 over 6. Okay? And go ahead and plug that in your calculator. What do you get? 68.2 degrees. All right, I have an angle here. Which two sides am I given? Opposite, adjacent, hypotenuse, both, all? Opposite and adjacent. This is my adjacent, this is my opposite. So what's the equation that I write? Excellent. So x is inverse tangent 7 over 13. How much? 28.3 degrees. Okay? All right. Now, this homework is due next class. And watch for the practice test. I'm sorry, the practice quiz tonight. Do the practice quiz tonight. If you have any questions tomorrow and you want to ask me, you can do that. Otherwise, that's that. All right?